slope of a line, or we could also call this rate of change. Okay, we'll talk about this a couple different ways. The standard, as far as Common Core, they like to talk more of it as rate of change. Traditionally, it's been called slope. A lot of different names here. So let's go ahead and move on. And this is the actual standard. Okay, this is the one that you're going to be assessed on. If I can actually get it here. There we go. Calculate and interpret the average rate of change of a function. Okay, presented symbolically or as a table. You should understand the table part, I hope. Symbolically, we're going to use equations, right? The symbols y equals 5x plus 20, something like that. So we'll do that over a specified interval. I'll explain it. That'll be a little bit later in there. Okay, today we're not going to necessarily talk about the specified interval, but we'll describe that as well. And then estimate the rate of change from a graph. So we're basically going to do it multiple ways. You're going to have to tell me what the slope is given an equation. You're going to have to explain what the slope is or the rate of change is given a table, or a visual representation and find it from a graph. Okay, so those are all the different ways, which pretty much runs the gamut there. Okay, so slope of a line. First, let's go back over something here. Let's talk about what is a ratio. Okay, so a ratio. We talked about this. This is a big thing in 7th grade. And a ratio is a comparison of two quantities using division. Okay, so slope is a ratio of its vertical change, which we'll call its rise, and its horizontal change, which we'll call its run. Okay, it's essentially this. You're comparing how much it goes up and down compared to how much it goes side to side. That's really what it is. Okay, rate of change is when we talk about this typically from a unit perspective, right? A unit rate, which means we want to know what it is when the denominator is 1. So for each unit of input, what would be the change in output? Okay, I'll say that again. When we do a unit rate, in fact, let's write this on here. Okay, a unit rate, okay, which is a type of ratio. It's whatever your slope is over 1. Okay, and so what this means is we want to know for how, right? Let's see. You want to know how much change the output changes for each input, right? So how much the output will change, right, for each change in input, right? And when we do this, we talk about one unit, each 1 unit of the input for each change in input. Okay, whoops. Input. All right, so m. We use m for slope. I just use it right there. That's the term for, or that's the variable we typically use for slope. So here's what m looks like: how much it rises compared to how much it runs. Okay, that's what it is. We're making a ratio about the change in the output compared to how much the change in the input happens, right? Or the rise compared to the run. So you're talking about the difference between the y coordinates and the difference of x coordinates. Okay, and again, really what the y coordinate is describing on a graph is the output, right? It's what comes out of changing the input. This would be your dependent variable, right? How the dependent variable changes compared to how much you change on the independent variable. All right, and the graph is just a representation of this, and we talked about this in class, especially with the problem with the awards banquet and changing the number of you change the number of tables on one side, and it changes the number of tables on or square tables on the other side. All right, so here's an example of a slope: 3 over 2. So what does this mean? This means for every 2 that I plug in, right? As the input increases by 2, the output will increase by 3. So for every time I plug in 2, right, or a change, increase it by 2, my output increases by 3. Right? Now this is not a unit rate. In fact, okay, if I wanted to change this into a unit rate, I would change this into over 1. And so 3 divided by 2 is 1.5. So I'd have 1.5 per 1. So for every 1 change in the input of 1, my output changes 1.5. Okay. We'll talk more about that later. Okay, but let's do this. Sorry, so comparing slopes. Quick review. Positive slope, that means as the input increases, my output increases, right? So if it rises, the slope is positive, right? Look, as I move across here, input increases, output increases. Positive slope. Okay? In this case, it's a one-to-one relationship. Okay, for each one I increase, right? As for each one input, or for every one of input, I get one extra output. Okay, input input an extra another one, output an extra one. Okay, it keeps rising the same as much as I input. All right, comparing slopes. Negative slope. This means as I increase the input, my output is going to decrease. Okay. And hopefully you can recognize this one. This line is actually, why don't you pause real quick and see if you can tell me what that line is. Okay, so hopefully you came up with y equals negative x. Okay, it's the opposite. In fact, let me go back. Here's the parent function, right? That's y equals x. This would be the opposite, right? Negative slope, y equals negative x. Okay, in this case, your slope is going to be -1. Okay. Sometimes you'll write it. Sometimes you'll see it written as -1/1, right? The negative in front, or really, what you could do, you just say -1. Okay, and this one has, in fact, a unit rate because the denominator is 1. Okay, so again, as I increase by 1, my output decreases by 1. Okay, and I guess this is sort of saying as I decrease my input, my output will increase. No, sorry, I said that backwards. It says this. The bottom is the increase in the input, right? So input, that takes care of this. Then my output will go down 1. Okay, zero slope. So what does this mean? This means as I increase my input, nothing happens to my output. Okay? So if you looked at this as I change my input here, right? As the input goes up, right? As my input goes up, nothing happens to the output. It is consistent. It stays. There's no change. Okay, and you might remember something last year when we did the interpreting graphs, where I would give you a graph and you had to tell me what the story was happening with it, or I gave you a story and then you had to graph the representation of it. Okay, so in this case, you have 0/1. Okay, because as I increase, right, as my input increases by 1, my output does not increase at all. All right, and then what I have is this undefined slope. And what does an undefined slope means? It means, okay, it's a vertical line. It means I'm not actually even changing my input. I don't change my input, and I get a whole bunch of outputs. Which, if you look at this, that's not a function, right? It fails the vertical line test because it is a vertical line. So that's why we call it undefined. It doesn't really work. Okay. All right. So go ahead. Why don't you find the slope of that line? Go ahead. Pause. Okay. Hopefully you we're able to calculate it as being 1. Okay, so there's a couple different ways you could do this. You could just plot a point. You could say, here's a point, right? That looks like it intersects at 1, 2, and find another point which looks like a 3, 4, and you could just count, right, from here to here. It goes up to compared to 2 output, right? And you could say, okay, 2 to the right, as it increases by 2, or as the input increases by 2, the output increases by 2. All right, and that's really what this is sort of saying. Okay, what this is sort of the more calculated version of it. What I did is I used the different points. So I said, okay, the top part is the difference of y coordinates, right? So this y coordinate is 2, this y coordinate is 4. So from 2 to 4, what happens, right? You could either say I go up to, you could say +2, or you could say 2 is 2 below 4, which is what I'm saying here. Okay, and this is, you'll see this a lot in textbooks, or if you do online help or something, you might even see there's an equation that looks like m is equal to, right, well, it's like a y2 minus y1 over x2 minus x1. All they're saying is the change in y and the change in x is the slope. Okay, so that's just using the coordinates, right? So this 2 is this y, right? This 4 is the y coordinate here. This 1 is the x coordinate here. This 3 is the x coordinate here. You're more than welcome to use that. I find that students make mistakes constantly when they use this, rather than just actually thinking about what slope is talking about. Okay, you're talking about the change that is happening, that's occurring, right? To me, it looks much easier to say, okay, from 2 to 4, it's going up 2 as it 1 to 3 increases by 2. So as I change the input by 2, my output increases by 2. So what's really happening? It's a 1-to-1 ratio. As I increase 1, I go up 1. Increase another 1, I go up 1 again, right? My output increases at the same rate as my input. Okay? And that's really all that's saying. Oh, so yeah, the slope is 1. That's another way you might see it. Okay? Why don't you go ahead and you calculate the slope of the line here. Okay, I see a point there. It looks like 1, 4. There's another one there that's at 3, 1. Down 3, right 2, negative 3 over 2. Okay? Pretty self-explanatory. If you have questions on this, maybe you just circle. We'll say, I'm not really sure how you quite got that. Again, this 4 is talking about the 4 at the y, right? The top is the rise. If the rise is how much it goes up and down, if I want to calculate it mathematically, I would say 4 to 1, right? If it was at 4 and it drops to 1, what happens there? How does that happen? Well, 4 minus 1 is 3, right? But what this is saying is it goes down 3, right? So I'm going down 3, all right? And then I go from 1 over to 3, so that's an increase of 2. So as it increases 2, I drop 3, and that's what this is saying here, okay? All right, moving on. That looks funky. That's supposed to say 2y minus 4x is equal to 8, okay? In fact, let's just go ahead and fix that real quick. All right. And back in. Hey, fixed. Okay, so let's find the slope of this one. How do I do that? So let's find intercepts. We need 2 points, okay? We know that a line is going to be a whole set of points, inputs and outputs. It doesn't really matter how you do it. To me, an input intercepts are often easy because they're quick to calculate, okay? Especially when this is written. This is written in what's called standard form, right? When y and x are on the same side. So you can quickly plug in 0. All right, and I'm going to get an x-intercept of negative 2. I'm going to plug in 0 for x. I'm going to get a y-intercept of 4. Okay, so I'm going to use those 2 points. All right, and you can pause the video if you need to look at the math on that. Okay, so I'm going to use these 2 points, negative 2 to 0. Now, there's a couple different ways you can do this. One is you could just plot it on a graph, right? So that's one way we do it, right? So plot on a graph, or you could use that you know, the mathematics on it, okay, from 0, right? What's the difference of 0 and 4? So we do 0 minus 4, and then what's the difference? Negative 2 to 0, negative 2 minus 0, negative 4, negative 2, right? Students get confused with this all the time. Another way of doing it is, and this is a lot of times how I do it, I know that the y is the part that's, you know, or the x is the first part, right? This is the input. So from negative 2 to 0, this goes up 2. All right, this side. And then I say from 0 to 4, what happens? Well, this goes up 4. So then I've already set it up here. I'm going to say, okay, so my output goes up by 4 as I increase my input by 2. All right, and that's really what is happening on the bottom here. Okay, you plug it in and you get a slope of 2. So for every 1 input, I get an output that increases by 2. Okay. Here's another one. Why don't you go ahead and find the intercepts. All right. I'm just going to plug those in. All right. You can pause the video, look at the math. Hopefully you got 6 and 3. Again, we can find the difference between them. Okay. So then I'm going to go from from 6 to 0, right? So I'm going to look at this. I'm going to say 6 to 0. That goes down 6. And from 0 to 3 goes up 3. So as I go left, right, as my input goes down 6, my input goes up 3. Well, that's a little confusing to say because most of the time we want the input to go up, right? So since this is a 3 and negative 6, what I can really say is I can say this is a negative 1/2, right? Because both 3 and 6, right, I could divide both of them by 3. So now what I'm saying is for every 2 units that I input, my output goes down by 1. Okay, which, if I wanted to write this as a unit rate, I could say is negative 0.5. So if as I input, every time I input 1, my output goes down by 1/2. Okay, or then this is the way this is sort of the mathematical traditional way, right? 0 minus 3, you find the difference, that's negative 3. 6 minus 0, that's 6. Same idea, you get negative 1/2. Okay, so that's the general idea. Let's stop there, and we'll talk about finding the actual rates of change tomorrow in class. Hopefully you took notes. When there were graphs, hopefully you graphed them, and yeah, we'll see you tomorrow.